Okay, having a look at question 2 on generating sequences. So we're given an nth term of a sequence. So this is a rule that allows us to generate a sequence. The way in which it does that, the letter n represents the position number in our sequence. So whatever position we're interested in, we replace n with our position number, and then we work out what answer we get from the expression. So if I want the first 4 terms of the sequence, that means I need the first term, the second term, the third term, and the fourth term. If I want the first term of the sequence, that is position number 1, I need to replace n with the number 1. So imagine replacing n with a 1. I'd recommend doing this on paper so you can work it out in phases, but I'm just going to talk through this. So replacing n with 1, in the brackets would have 1 plus 1, which is 2. And then 9 is next to the brackets, which means it's times in the brackets. So 1 plus 1 gives us 2, and then 9 times 2 is equal to 18. Looking at the second term is position number 2. So I now need to replace n with 2. So 2 plus 1 makes 3. And then 9 times 3 would give us 27. Position number 3, so the third term, I replace n with 3, so 3 plus 1 is 4. 9 times 4 is 36. And then position number 4, replacing n with 4, we'd have 4 plus 1, which is 5. And then 9 times 5 is 45. What is the 20th term? Well, the 20th term has position number 20. So we replace n with 20. So 20 plus 1 is 21. And then 9 times 21 should be something you could work out, no problem. Would give us 189 if my mental maths is correct. Okay, what is the first term to be larger than 100? So this time we're working backwards in a way. We have to think of what position number will give us an answer that is bigger than 100. Well, there's quite a few that gives us something bigger than 100. We want the first term that will give us an answer bigger than 100. In other words, what is the smallest number I can replace n with? The smallest position number. It gives us an answer bigger than 100. So if we choose something quite big, so let's say, for example, if I choose n equals 10, so the 10th position, well, 10 plus 1 would give us 11, and then 9 times 11 would give us 99. Now, 99 is super close to 100, but it's not larger than 100. So the 10th term, giving us 99, isn't quite big enough. So let's have a look at the 11th term. So 11 plus 1 will give us 12, and 9 times 12 is 108, and that is larger than 100. So the first value that gives us an answer that is larger than 100 was the 11th term. The next question, exactly the same sort of idea. I'm not going to run through the whole thing. It should give you an idea how to approach it now, though. Just give you an idea just how to start. So I've got a brand new rule here. So n outside the brackets and then n minus 1 inside the brackets. What are the first 4 terms? So position number 1, position number 2, position number 3, and position number 4. For position number 1, we replace n with 1. But notice how there's 2 places where n is. So each of these places have to be replaced with a 1. So starting with the brackets, following bit maths, we're going to have 1 minus 1, which is 0. And then 1 outside the brackets is times in the brackets. So 1 minus 1 in the brackets gives us 0. And then 1 times the brackets, 1 times 0 will give us an answer of 0. If I'm looking at position number 2, replacing n with 2, I'm going to have 2 outside the brackets and 2 inside the brackets. I'm going to have 2 minus 1, which is 1 inside the brackets, and then 2 times the 1 inside the brackets will give us an answer of 2. Let's just do one more. Third position, when n is equal to 3, I'm going to replace both n's with 3. First thing I'll look at is inside the brackets, 3 minus 1, which is 2. And then 3 times 2 will give an answer of 6. The rest of the question is very similar to the one above, so I'll leave those for you to have a little go at. I'm just going to mark what we've done so far, and we've done pretty well so far.